Want to be more thorough while also working faster? It doesn't matter if you're on the red or blue team, an augmented reality overlay can enable you to be more thorough and faster at the same time. No glasses, no goggles. Polarity delivers this superpower as an overlay on top of your existing workflow and tools. The free Community Edition connects to the data you care about to overlay the context you need to make informed decisions. Apply for early access today at securityweekly.com/polarity. Hackers attack systems that are not patched. You need protection, but virtual patching isn't working. That's why you go patchless. Topia analyzes, prioritizes, and remediates vulnerabilities before they're exploited. Even the 0 days, all from one interface. Security gets better memory defense to complement endpoint strategy while improving overall vulnerability management and compliance. Adopt a hacker's mindset, eliminate vulnerability. Get your 30-day free trial at securityweekly.com/vicarious. Are you an enterprise dissatisfied with overpriced analytics software that can't keep up with modern data? If so, then GravWell is the solution for you. GravWell is an unstructured data analytics platform for enterprises who demand total data visibility across their network. GravWell lets your security team go beyond the SIM and fuse data sources to correlate and answer questions you didn't know needed to be asked. Go to gravwell.io/securityweekly for an unlimited data trial and gain uncompromising visibility today. Welcome back, everyone, to Paul's Security Weekly. In our upcoming webcast and technical trainings, you'll learn how to prevent phishing scams, how to move beyond vulnerability scan to vulnerability fix. You can also visit securityweekly.com/webcast you've got coming up, or visit securityweekly.com/on-demand to check out our previously recorded webcast. This segment is sponsored by Secure Circle. You can visit, I totally messed up the order of my cough button. You can visit securityweekly.com/secure circle to learn more. Joining us in this segment is Jeff Capone, the CEO of Secure Circle. Jeff Capone returns with us to talk about zero trust data security. securityweekly.com/ oh, that was for the I'm just really messing up the beginning of this segment. I apologize. Jeff, welcome back to the show.
Thank you for having me back.
Jeff, I wanted to first point out actually an article that I had today, because we've, as all of us have been in information security for a really long time, and I think that the crux of what we're trying to do in information security is protect the information. You know, as the famous line in sneakers, it's all about the information. And we'd think that by this point in 2020, we would have been able to protect information, except then I saw this article that said the biggest hacks and data breaches of 2020. And it starts out in just January of 2020, there was 6 data breaches. One of which is actually pretty funny. It was a medical marijuana dispensary and a database backing the point of sale systems used in medical and recreational marijuana dispensaries was compromised, impacting an estimated 30,000 potheads. I mean, U.S. users. And the list goes on. And I'm like, if we have really truly solved this data security problem, there'd be a lot less, hopefully zero, bullet points under each of these months for the number of data breaches. But there isn't. The list goes on for pages and pages and pages. And we've got things like DLP. We have lots of different options for encryption technologies. It's apparent to me, Jeff, that a lot of this stuff just is not working. What can we do better?
So, I think the big thing is that data has to move, right? Data doesn't necessarily stay.
Data wants to be free. I think
it has to move, right?
Yeah.
I'm sorry. Did you want to add something to that?
I was just going to say, like, data wants to be free. I think it was during our webcast that kind of thought, it occurred to me that it really does.
So here's the thing. One way to think of it, you mentioned a database, right? So, underneath the database, it's storing blocks, or whether it's storing the data on a file system as the file store, or the blocks as a file store. The database is writing to some storage mechanism. And if you really want to be secure, what would you have to do? If someone wanted the database, you'd have to give them the I'm just being over dramatic. If you wanted to give them the data and keep the data secure, the best way to do it would be to take that hardware, because that's where the controls are. Everything keeping that data in that database safe is in the hardware that's storing those bytes on those blocks, and actually hand them the hardware, right? Like literally,
Mm.
that would be the
Right.
safest way. If that was the only way you could move data, which would be impractical, that would be the most secure way.
Provided you validated whoever you're giving that to is a trusted party.
That's true,
Right.
of course, right? But in reality, the data wants to move, and the only way you could really move the data in a secure way. By the way, this is our old logo. That's why you see this in an old jacket.
Yeah, I was wondering what the logo was on the
Yeah, it's
jacket.
our
Yeah.
old logo. So the only way to actually move the device, reason being, is because the security for the data in the device is on the device. So the only way you can actually move that data in a reliable, secure way is to actually move the device, because that's where the security is. But that's not practical. Data has to move and data wants to move, right? So if you start thinking, well, what am I moving when I actually move data? Well, I'm moving bytes. Well, why can't I keep those bytes encrypted while they move so that I'm effectively moving the control with the data, right?
Mm.
So if you want to think about moving data, you can start actually think about moving the physical device and then seeing, okay, how can I virtualize that device in a way, which really is the file system, so that when I really move the data, what I'm really moving is some virtual hardware,
Mm. Oh,
right?
that's interesting.
Right. So why can't I make the file system sort of portable, if you will, right? And if you think about what data really is when it's on some sort of system, just take a file as an example. What's really the file? It's the blocks underneath the file that actually make up the data, the actual physical media, or whether it's hard drive spinning or it's SSD. There's some sort of physical media under there that's actually doing the work of storing the data. So one of the things we like to talk about at Secure Circles, we like to say, to make it simple, we encrypt the bytes inside the file. But no, what we're really doing, just like an encrypting file system, we're encrypting the blocks underneath the file, the bytes that make up the file. It's really underneath, but it makes it easier to explain by saying inside the file, right? And then the interesting bit is when you want to read stuff off of media, I can choose whether or not when an application or process reads the media for isolated consumption versus reading the media to move the data, right? So if I can distinguish whether or not an operation to read those bytes underneath a file, I'm using a file example, but it could be a structured store as well. If I'm making a decision based upon the access request of what needs to read those bytes underneath the file, I can make a decision whether I serve up the encrypted bytes or a range of the unencrypted bytes to that process. So if something I know is going to read those bytes but not move the data, I can serve it up the unencrypted byte ranges that it requests. But if I know something's going to move the data, or if it's a process I know that's going to move the data, or a process that I don't know that I can speculate might want to move the data, then I just serve it up the unencrypted bytes. So when it goes and lands somewhere else, it can still be reread. So effectively, you can think of it sort of moving the device to move the security with it, right? So how
But
can
now,
you?
Jeff, you didn't just like wake up one day and go, I want to read about file systems because I got this idea for security. You had a background in this before you came up with this idea, correct?
Sure, yeah, I'd done some work on developing file systems and looking at how to optimize their performance. And to be, this is a fundamental question that I literally asked myself one day. What is a file? Like literally, what is a file? And I remember I had this thought, and I don't know if any of the audience members out there have a storage or a file system background, but if you think about iSCSI, for example, and now we're going to go deep, if that's okay.
Yeah, please do.
Because this is sort of the genesis of my thought process back in the day. So iSCSI is a protocol to expose block storage over a network, like Fiber Channel, but it's IP based. So you can use a file as a piece of block media, right? That's called a LUN. So theoretically, I think my MacBook here, I could create a file on my MacBook, which is really just reserving a bunch of blocks on my SSD inside my Mac. And then I can expose that LUN, which is really just a file reserving blocks on my hard drive on my Mac. And it can expose those blocks, which really are being reserved by the file on my Mac, over a protocol called iSCSI, right? So it's SCSI really over a network is what iSCSI is. And SCSI is the protocol you use to read your actual local drive. But instead of reading your local drive with SCSI, you're reading this remote drive over your network using an iSCSI protocol. Okay, so I have my LUN on my Mac. I expose that LUN, which is really just a file, but just a bunch of blocks really on my Mac, over iSCSI. Let's say back to a NAS. So the NAS now sees this disk, which is really just a file on my Mac, as block storage, so it can go and format a file system. Let's say it puts ext3 on that file. It's a Linux NAS. It puts ext3 on that LUN that I just created, which is a file system that's on the Linux NAS. And now that Linux NAS exposes that a folder on that ext3 volume back to my Mac using, let's call it SMB protocol. So now I mount that SMB folder, call it Jeff's folder, back to my Mac, right? So I have this kind of loop, right? I have a LUN on my Mac. I expose that LUN over the network to a file to a NAS. It formats a file system on this block media, which is remoted into my NAS. And then I mount it back to my Mac. And now my Mac has a folder mounted to it. And I save a file to that folder. So the question is, where is that file? Is it on the NAS or is it on my Mac? Right?
Yeah, I'm not.
So
I actually don't know the answer to that question, Jeff.
Where is the file? Right? Is it on my? The NAS, the Linux NAS, has the file system. My Mac has the blocks.
So I mean, it's on your Mac because your Mac has the blocks.
But can it read them? Right? Let's say the Linux NAS encrypted the volume, which was my LUN.
Are you saying could the Mac read the file?
No, the LUN on my Mac is just a file.
Yep.
Right.
Exposed over iSCSI to a NAS.
Okay.
The NAS takes that LUN, which is really just a piece of media,
as a share,
and formats it with a file system.
Okay.
And it could be an encrypting file system.
Yep.
I could turn on encryption on the NAS. So the blocks that are acting as storage on my Mac are encrypted by the NAS. The NAS puts a file system, an encrypting file system, let's say ext4 or ext3, if that supports encryption. I'm not sure if it does, but I'll just pretend it does. And then I share that folder on that file system on my NAS back to the same Mac that's hosting the LUN over iSCSI. And I save a file to that remote share, which is kind of remote because it's on the NAS and it's exported over SMB or shared over SMB. But underneath that SMB folder is the ext file system that lives over the NAS. But underneath that ext file system is really the blocks that are on my Mac.
So the Mac wouldn't see the blocks directly, but they're there. Well, they're there.
They're there, so they're just accessing them.
But I mean, in the file system, you wouldn't see them because they're just blocks.
But you would see the file that is reserving the media on my Mac as a LUN. I'd have to declare that file on my Mac, call it LUN1.
Okay, yeah. Then
right?
You would see
that would be reserving the media on my Mac so that I could present it as a piece of block storage, a LUN, to my NAS.
Yep.
Right? NAS puts the file system on it, and then shares it back to me over SMB.
Right.
So what I've effectively done is I've separated block storage from the file system.
Yes.
Right? The blocks live on my Mac. The NAS, the file system lives on my NAS. And now I can truly control access to data that's really on my Mac. So now we come to this philosophical question: what is data? Does the Mac really have the data? Maybe. Well, there's no real storage on the NAS. How can the NAS have the data? So the data must be on my Mac. So now I can control access to blocks or bytes on my NAS by something remote over here, the NAS.
Yes.
What does
Right? So
the
now
what
the
does the
net
overhead look
has
like for that?
control over local data that's on my Mac.
Well, in Jeff, I think you should also then segue into how the product works, because you've told me how the product works, and now that you've told that whole
I don't do this in the product,
right?
But
Yeah.
conceptually, it's an easy way to explain.
Now it makes
how you
more
can separate block storage
Yes.
from a file system.
Yeah, I'm putting all the pieces together in my head, and I think that's probably where Tyler and Doug are questioning is how does this tie into how
we don't implement it like this.
No,
but
no,
conceptually,
of course. Yeah, conceptually,
it's the mental journey I went down before we started this whole endeavor. Right? So you ask yourself a lot of fundamental questions like, what is a file? What really makes up a file? What makes up a file system? Right? And how to really separate those two things so that data can move around, but access control can still be centrally managed.
And then Jeff, how does it work today? And you've given great examples on how you protect source code and other things. How did you take that concept, right, and then turn it into a way to protect data today, independent of basically where it's stored?
Right. So, I mean, it really just boils down to understanding literally how a file system works and being able to really getting back to what I was talking about before, understanding on how to return bytes that need to be read based upon now, not just the local file system permissions, which manage the file system, but being able to pull that access control plane out of the endpoint into something that can be centrally managed. So the central management now can make decisions on how bytes can be read locally on a device and decide, are these bytes being read because they need to be consumed locally and aren't intended on leaving the device? So in other words, is this Windows Explorer or Mac Finder? If it is, then I'm not going to let you read the bytes. You should just move those bytes, and which means you should move the encrypted blocks and just move them either a USB drive, an email attachment, an upload. But if you're something like, let's say, a CAD application, you have a legitimate reason to read those bytes. So I can allow that AutoCAD application from over here to read the bytes that are locally here on the endpoint. But maybe I don't want AutoCAD and I want SolidWorks to be able to read those bytes, assuming they can consume the same file format. Then I can disallow SolidWorks and allow CAD or vice versa by controlling which processes now are allowed to access. And of course, I can incorporate the user, but now the user doesn't have to be a local user on the device. I can start now controlling these read operations based upon the process and the user that is remotely authenticated somewhere else.
And how do you deal with the performance aspect of it, Jeff?
So it's just a read operation, and the only difference is you have to decrypt a byte range. So literally, the performance overhead of what we do is no different than an encrypting file system. In fact, I mean, one way you can look at what we do is a portable encrypting file system. So if you think about the only way an encrypting file system is portable is in the only really access control you have is physical access control, right? So an encrypting file system, I turn it on, the whole disk is encrypted, and I have access control because only this endpoint knows the key, and when it boots, I can enter it in and it boots up. So if I actually physically move that drive, I don't have access because I don't have the password. I put it in somewhere else. I'm not going to be able to authenticate and read the data on that drive. So an encrypting file system just is kind of what we do, but we have a heck of a lot more granularity to how those bytes move and how those bytes can be read. So in an encrypting file system, you let any process read the bytes on that file system in an unencrypted way. But if you could actually discern some processes which are allowed to read and some that aren't, then things that actually move the data, you can conceptualize them as really just moving the blocks that are on that disk, which are encrypted. So literally, if I'm an application that's not allowed to read decrypted bytes, and I go to read them in order to move them, then I'm really fundamentally, you can think of it as I'm just moving storage. I'm not moving data.
So does this have the ability to leverage things like Opal or the hardware encryption that's getting built into a lot of the drives, where it can offload some of that resource-intensive decryption to the physical hardware?
Absolutely. So two things, Dick. So actually, I went on a tangent, and I apologize. The question was about performance. So really, the nice thing about what we do is just like an encrypting file system, we only return the byte range that needs to be read at any given point in time. So literally, you're not decrypted. The file could be gigabytes big, and if you only need to read a couple hundred megabytes, then you're only decrypting a couple hundred megabytes. And we do offload, if the hardware supports that, the acceleration to the onboard AES 256 acceleration operation. So literally, there is no performance over. I mean, literally, it's the decrypt operation. And if you think about how a file system is read, you're reading essentially one block at a time. And really, think of it as almost like store and forward. So you're only going to pay the price for one block read, because you read one block, you can decrypt it much faster than you're even done reading the second block. So as long as you're reading a large sequential range, the overhead is zero, or essentially zero. The only time you'd actually start to see performance introduced on an encrypting file system, or what we do, is really with heavy I/O, right? So if you're actually doing a lot of small reads and small writes, small reads, small writes. But if you're doing just big reads, then literally there's absolutely virtually no overhead at all.
So is this a system level determination, or an application level determination, or a user level determination, or all of those things?
So it's user and processor applications.
Okay.
So what you do is you look at you manage an access list based on users and processes. So you say, is this the right user, and is this an allowed process to read the data that is being requested at that point in time?
And is it granular enough so that if I open a database and Tyler opens a database at the same time, and we don't have access to the same things, that's going to be so that just the blocks I'm trying to look at, I'm trying to pull up a record, those blocks are going to be decrypted for me. But if I try to look at records I don't have access to, those are not going to be decrypted.
So we do work at the file system level, so we wouldn't be able to work inside of a structured store and
okay. That's fine. No, that's okay. That's fine. I'm just trying to kind of establish the level here, so that made it much clearer. Yeah. Okay, I get that.
But
so
Jeff,
basically, this is like micro-segmentation and zero trust via the file system and at a storage block level, correct?
Mm-hmm.
I'd say
essentially right.
I agree with that.
Yep, I agree.
That's exactly
At least
right.
that's what I was getting. Yeah.
But now you allow an application to read. That doesn't necessarily mean that application can then take a copy of that data and save it out, correct?
Well, if it was an application that could do that, so if it was an application that could leak data, then you don't want to put it in the allowed list. And then if it is an application that has to read data and still has the ability to exfiltrate data, now we're talking about depth, right? So now what happens is, and this is what we do, you follow the data, right? So if this application, let's say WinSCP, so we have a lot of customers using WinSCP in the allowed list. So WinSCP might have some legitimate reasons for wanting to read the unencrypted bytes or read the data, right? The actual data. Although WinSCP would typically not be an allowed application, because all you're really doing with WinSCP is moving it. But let's say there is a legitimate reason you want WinSCP to actually read the data in an unencrypted way, not just move the data or move the blocks, as I like to say. We have the ability now to say, oh, if this process now has read the data that you want to secure, let's put firewall rules at the process level around the process, so now we can control where that process can write data. So if I'm going to allow this process, which does, let's say, have network access to read the data, then I want to control where it can write the data to by basically limiting network activity or where it can write, or limiting network activity altogether, or restricting it to an IP or a subnet, basically an application level firewall at that point.
Yeah. So that's how, if I inject into the process that can't access to the data, it's really hard for me, if not impossible, to get it out based on the policy, correct?
That's correct. Right.
And so is there, so again, this was kind of, I was reading a thread on Discord, but so if you had, like I say, a tool that didn't need to actually display the data, but just wanted to move it, data could be accessed and moved encrypted.
That's correct.
Yeah. Okay. Yeah. So that's, I get it.
I spent time with Jeff.
If you're just moving, like WinSCP is a bad example, like that should never be allowed to read. It should only be allowed to read the encrypted bytes off of the blocks underneath that file, right? But I don't know why I picked that example, because we do have customers that do that. I can tell you the use case. So they receive customer data through an FTP location, and they have a bunch of manual ETL processes that they do with all this PDFs, images, Excel documents, all sorts of file data. They receive it through this FTP when they're onboarding their customers into a tenant in the cloud, and they secure it with Secure Circle so that when these folks are working on populating that tenant, literally manual ETLing the data, it's always secure and only available to those applications. So if it ever does exfiltrate out of their environment that they're working on to onboard the customer, all that data that went into the FTP server is automatically protected. So then they bring it out, it's encrypted, they use it in uninterrupted, because it's they just the process and applications they want to use to read the data still can read it as they normally would. But if something moves the data out of that environment, they call it a clean room. If they move it out of the clean room, then it's garbage, right? Because those devices or users wouldn't have access to read those encrypted bytes that now land on these foreign endpoints. But they do have a use case for having WinSCP in the allowed list. So what they do is they need to get the data back to their end customer. So their objective is to keep their customer data, always secure when it's in their possession, have a full audit trail of that data, be able to destroy all that data and any odor of that data that they left behind after they onboarded the customer by essentially destroying the keys. But when they give the customer's data back to the customer, it's the customer's data to keep their own data secure. So they actually have WinSCP allowed to read the data in an unencrypted way and copy it back to that FTP server so the customer can go and pick it back up. Ideally, we would have liked them to have their customers get Secure Circle installed as well, so that they could continue to secure their own data once it's back in their own possession. But our customer in this particular case wants to show them that they're a good custodian of the data they receive, and they can supply a complete audit trail and revoke access to any data that they had created, even derivatives. I think I'm not sure we've talked about how we handle all the derivatives that get created from all this data that's received. But they can destroy all that, all its copies, all its partial copies, and everything else just by destroying the keys and give it back to us. So that's an example, a long-winded example of when SCP would be in the allowed list in that case.
I'm always asking Jeff and his team like all these creative things. And largely what it came down to is I can stand behind the user or have the user take pictures of their screen with their cell phone, right? That's only going to get you so far in data exfiltration. But right. Jeff, if there's malware on the system that's taking screenshots, does that still works? But that's almost self-limiting in and of itself because it's very time-based and only taking a snapshot of what's on the screen at any given time, correct?
Yeah, and we are releasing controls so that if that window is containing data that you want to secure, then operations on that window can actually be allowed or disallowed as well. So it's about following the data through the endpoint and putting controls. That's more of a depth control around the item. In this particular case, it could be the clipboard that's holding an item you want to control. It could be a window, right, that's actually having the data that you want to control. And so depending upon the processes that are allowed or not allowed to basically do operations on that window, you can define those as well. So that's more of the depth-based. But one of the things we really always like to talk about is the breadth, because really saying, do you support SolidWorks? Do you support this? It's like saying, does a file system care what data is being written and read to it? It really doesn't, right? I mean, if you want to get into the nitty-gritty, we even support memory maps. So even if a file is secured by Secure Circle and an application wants to read it to execute it, it can. If it wants to read it to memory map it, it can. All those operations work with data that's protected by Secure Circle. And we have to, right? Because if you think about source code, which we've talked about on a few episodes, a lot of IDEs and build tools will memory map files, configuration files. I'm not so sure if they actually will memory map source code, but definitely they memory map configuration files and these types of things.
Well, they also don't require that you, in the old days, like hit Control S all the time. Like I noticed when I use PyCharm, for example, it automatically saves stuff. Like as I'm making changes, it's interacting with the file system to basically just keep saving that on the fly, which I still being old and curmudgeon-y, I don't trust. I'm still like got my VI emulation mode, and I'm like :W all the time to save a file because I don't want to get out of that habit if I'm not in PyCharm. But they're interacting with the file system in also a very specific way, correct?
Right.
But so what about complexity of the access controls? Is that a big enough problem, or are people really they get them starting simply?
Yeah, I mean, so you can get. I mean, really, what we do is this kind of goes into where is your data type of concept, and for the most part, I always mention it's not like users are generating PCI or PHI or HIPAA data on the endpoint. It's coming from somewhere. So when it comes to where's your data, it's for the most part people can point out where their data is. Do they have to go out and discover? I like to joke around and say, well, if I gave you a discovery tool, where are you going to point it? So wherever you're going to point it, you've already discovered it. So one of the things we like to talk about is, what type of control do you want to have over your data? So getting back to the database example, as long as the database data stays in that physical device, the hardware, it's secure. It only becomes a problem when the data is going to leave. And that's when exploitation happens. So that's actually where we come into play, right? So we say, okay, you do a great job controlling access to that front door of the house being the database in this example. You make sure you validate the user, check their ID. Okay, you can come in. You let them in, and you let them take things from you because you hope they're going to do the right things with the things they took from you, but you've lost control of those things they just took out of the house. In a traditional way. So what we do is we say, okay, that data stuff in your database is important. You spend a lot of time making sure that front door has a good lock on it, and you have a bouncer in the front there to check the ID. So why not just extend those same controls you have over the data while it's in that structured location as it moves in an unstructured way onto endpoints. So just really mirroring the same access control policies you have when it's in these structured locations to when it becomes unstructured and winds up on the endpoints. We usually just have our customers take those same policies and extend them. So in other words, if it's sales data in Salesforce, I just extend control to that data that just left Salesforce, whether it was a CSV or what have you, or whatever came out of Salesforce, I just extend it to, for example, my access control group, which might be sales team. So no matter where that data goes that just left Salesforce, just like the Salesforce AD group, if it's AD, could only log into this section of Salesforce and export the reports, then only the Salesforce team that receives those reports or derivatives of those reports will be able to access the data that's on the endpoints now. So it's really just mirroring the same access controls you already have and identifying the data and the policy you have on those data locations.
So where are we keeping all that defined?
So we have a SaaS offering that keeps track of that. So as an endpoint ingresses, if you will, the data that's egressing out of these locations, we take an inventory of all what's happening, and all that data is being stored. The metadata about the data, so to speak, is being stored so that you can have, or our customers can have, complete access control now over that information now that's went from a structured to an unstructured way, and now is on an endpoint.
And Jeff, how does this play into the ransomware threat?
Yeah, we get that question a lot. So there, in my view of ransomware, there's two parts to ransomware. I'll encrypt the data that's on your endpoint or on your server, and I won't let you have access to it until you pay me. So the solution to that is proper backups, right? So if you're taking proper backups, then you can get the latest version. Depends how quickly you're doing your backups and how frequently, I should say, you're doing your backups. But that's the best solution to that aspect of ransomware. The other part of ransomware, which is actually becoming more popular, is I take the data and I'm going to tell the world what's inside the data unless you pay me. So we do a great job protecting against that threat, because if ransomware is a process that's not an allowed process and reads data off of your device, all it's read is encrypted blocks. And unless it's a trusted device and a trusted user, then it's not going to be able to in a trusted process, it's not going to be able to read anything that it just took from you.
Okay. So what's that do to the ransomware recovery scenario? Like we hear about companies, they shut down all the impacted IT and then they're rebuilding it. You're in a SaaS does this sounds like it get really complicated, or am I misunderstanding?
So no, not really, because what you do is just put your backup application in the allowed list. So your backup will read the data in an unencrypted way. So then you restore, and we detect that the restore on an endpoint, if it was a trusted endpoint, those bytes that you get restored back on the endpoint are going to be in the exact same state as they were when they got backed up.
Okay.
When I say that same state, I mean the encrypted state. So whatever you're using for a backup utility, you make that an allowed process. So the backup is unprotected. And then when you restore the backup to the endpoint or the server, we'll recognize that those bytes are something we've seen before, and we'll protect those bytes just like they were before they were backed up.
So I don't have to go back and reconfigure your service once I've recovered. It says, hey, I know I've seen this before. We're good to go. I'm back where we were.
Exactly right.
Okay.
So basically the trick there is just making sure the backup application is in the allowed list. In fact, a lot of people ask, well, how do we divorce, right? It comes up every so often. We buy into your world and we protect all this stuff. Well, how do we divorce from you in case we don't want to use it anymore? And the simple answer is, just put your backup application in the allowed list, and then all the copies of the data that are taken off of the endpoint or off the servers is not protected any longer by secure circuit, because you just moved the data, and with that move operation read the unencrypted bytes.
So can I'm going to ask a question about that, because one of my great, I don't know, I'm sure it's a biased paranoia about encrypted operating systems, encrypted file systems, has always been, can it become corrupted and I lose all my data and I can't get it back? Because I've had people do that with various and sundry tools. So how do we prevent that from happening because of some kind of corruption or change to the system?
So I mean,
also, I think just to add to that, since you're answering the question, does it have the ability to be able to be centrally managed by something like Active Directory, where you have something like BitLocker or SCCM doing or Intune doing that remote management of a myriad of enterprises' device?
Yeah. So for example, we have customers that use Vontu to scan data that's protected by a secure circle. So Vontu goes in, or Symantec goes in the allowed list, and they can still scan and look for confidential data and data that's protected by a secure circle. I'm sorry, I think there were a couple of questions there. So we don't hinder anything that can be currently done with the data. I think I might have lost track of the other parts of the questions. Would you mind? Centrally controlled? Yes, yep. It's absolutely centrally controlled.
Okay, well, yeah.
And you can use any identity provider you'd like. So we don't have any notion of users in Secure Circle. So the access control list, so we allow you to create for your data, we allow you to put a policy on the data, and you can bring your own users, so to speak. So if part of that policy is only the users in the Salesforce security group have access to it, our server side will check your identity provider to see if the user that is logged in, whether they're logged in through SCIM or logged in through Active Directories, we'll check that token against the security group to see if the user is allowed, and if they are, then their process on that endpoint that is trusted gets to read those bytes that are in that what we call circle or data group.
So is that handled through like something like OAuth or single sign-on, where you're able to integrate multiple authentication methods? I'm assuming like Kerberos or single sign-on or LDAP, sure, for example.
So it's AD, LDAP if you want to go directly to the identity provider, and we're releasing SCIM support early Q1. So you'll be able to go through SCIM to SCIM to whatever identity provider you're using behind that. So right now, what we do is on the endpoints, if they're, let's say, domain joined, we'll just pick up more or less the token that gets created when they log into the device. But you think of SCIM, nobody's logging into devices anymore. People are just logging into their identity provider. So we basically will get the token from the identity provider and use that in our agent on the endpoint to go validate against the security groups that the identity provider behind the SCIM is using.
But my question was about like how is resiliency maintained from something getting corrupted and then all my data is encrypted and I can't recover it because this change has happened, and I don't know enough about the product to know what that change would be, but how do we prevent that?
Sure. So I mean, there's one key per file. So every piece of data, every unique piece of data you generate that's inside a file will have a unique key. So as long as you have access to the keys, then you could always decrypt the data. And so we can talk about how we manage the keys. We integrate with the HSM that you want to use, the KMIP server if you want to use that. So you can always make sure you are. So our answer to that is, if you're really concerned about us losing the keys, then you manage your own keys, right? And so that onus is on you. And what we can say, as long as you have the keys, you can access the data even without us, because essentially there's a structure to how we store data, and it's documented, and you could literally, as long as you have the keys, always recover that data. The other part of your question when it comes to file corruption. Well, file corruption is something that any file system could happen on any file system. But when you build file systems, you do things like journaling. Just to give you an example, we make sure that if we had a hard power outage when we're creating data on a disk, that we're fault tolerant to that. So basically, anything a modern file system will do happens with data that's protected by a secure circle. So sure, any file system has the potential for data to be corrupted, but there are standard practices when developing a file system of what you need to do to prevent against that.
Well, yeah, I was thinking more like file corruption in the sense that if those keys are derived from, like, for instance, there have been systems where the keys are derived from hardware, and you were talking earlier about, pulling a drive out of a machine and putting it in another machine and won't read anymore. And I was just wondering, how, and I mean, mostly this is just like, how does that work? But it's like, how are those keys protected from things like that, or are they not generated relevant to the hardware? So
the keys are all centrally managed, right?
Okay.
So you bring one master key, and it's
okay. I mean, that's really more what I was asking about that, because that's where a lot of my paranoia was of some of those early encrypted file systems, because they were like, I remember we had one once, and it, you changed the memory, and the encryption changed, and it caused all kinds of problems, and there were hardware issues along with the file system, which made me really, really paranoid about these kind of things, because I remember,
in fact, we hear that from our customers, right? We have a couple accounts that now that they've identified the data they want to protect with Secure Circle, and they're protecting that data, they realize they don't need full disk encryption because the data that they have is already protected. So full disk encryption is just giving them more pain than anything. Actually, it's not even giving them any security.
Absolutely.
It's and forget me, I'm sure you guys will know, but it's 130.2 or 130. What is the regulation? The FIPS regulation? I can't remember which one it is. Sorry, the PCI. So
FIPS 140-2.
Is it 140-2? Yeah. The one that everybody interprets as full disk encryption. It says disk encryption, but it also says file encryption as well, right? So if you actually read it, we can show audit trails that all the data that is in scope is protected by Secure Circle, so you don't have to worry about that, because we hear that quite a bit. What you just mentioned about having to enable a hardware dependent key that's on the device. I mean, and people just can't even boot their machines, right? So the worst case, if you can't access keys with Secure Circle, let's say we have caching policies and all this other stuff, time to live you can set, but let's say your time to live expired and you couldn't go to the server to reheat the token, couldn't get the keys anymore, and you wanted to get on your device, you could still get on your device. Your device would still boot, unlike something that's doing full disk encryption. But you just wouldn't be able to get to the data that was protected by Secure Circle.
Okay. Thank you,
Jeff. That was awesome. I'm glad we got a chance to get nerdy.
We haven't done that before. I've been all sort of more markety.
Yeah, just like I'm the corporate CEO, and then comes here and lays it down. I love it. It's awesome.
Thanks.
Jeff, anything else you want to share with our audience today? New feature announcement, things of that nature. You mentioned a couple actually already in the segment.
Yeah, Skim's coming out. What else really? All incremental stuff. I mean, one of the things that we're just hyper focused on is just usability, right? So I mean, just making things more usable. I mean, everybody is in some ways, wants a consumer experience, even for enterprise products, right? So really just making sure things are just dirt simple to use. And that
I'll ask the question for those poorer of us. Is there a demo version that we can have to play with this for those of us who can't probably afford to buy a working version.
I mean, there isn't anything that's one of the things that is on the tentative roadmap for next year, is a self-service version. We could talk about disrupting the sales model too, right? But that's maybe a topic for another day for enterprise sales. But if you want to contact us, there's a link on the website to book a demo, and we have a good team that will be happy to walk you through a demonstration, even give you a trial version and set that up. But I mean, it's less than a day turnaround if you click that book a demo link, either in booking a demo to actually getting a trial environment. We spin them up very easily. It's auto provision tenants we can create. But yeah, we're going to do a self-service version where we'll create a domain for you, acme.securecircle.com. You'll spin it up. You get to play with it.
Does this have the ability to do on-prem deployments for some of those environments that are a little bit more rigorous around that kind of thing?
Yes. Yeah. So our back end is all containerized. We try to stay away, but we have some large financial customers that don't want anything running in the cloud, because we do integrate with their Active Directory server. We do integrate with their key server. We do have state, and we manage a database, or we can actually drop tables in our customer's HA, let's say SQL environment. So we have the ability to just drop the table. So literally our front end becomes completely stateless and horizontally scales with whatever Docker Compose environment they have on-prem. And they manage state in there. We delegate the state managed onto their HA environment, and we integrate with their key servers, and we integrate with their identity provider. So yeah, in those cases, for the larger guys that want to do that, because we're touching more sensitive systems that are on-prem, we do that.
Jeff, thank you so much for appearing on Paul Security Weekly tonight.
Oh, my pleasure. Thank you so much, guys.
For folks who want to learn more, visit securityweekly.com/secure circle. Stay tuned. The security news is coming up next.